All right. Thanks everybody for showing up. We only have half an hour slated. I don't know if I could do this quickly. It's been a while. Also, I'm a little bit out of practice with my zombie brain talk. So let's get started. Let's see. Let me share my screen here. And this is, hopefully you can tell, a pretty informal talk. So feel free to interrupt and ask questions. Ton, can you admit people as they come in? I'm going to lose the ability to keep admitting people. And is that being shared properly? Everybody see the main title slide there? All right, cool. So welcome. Thank you everybody for showing up. If you haven't taken a class with me or run into me yet, then I'll introduce myself. My name is Bradley Voytek. I'm a professor in cognitive science. And I'm also part of the Haligiolu Data Science Institute here and the Neurosciences graduate program. And, oh, you see the presenter view, Q? Are you not seeing the slide view? You can unmute, Q.
Well, we see the slides, but there's the current one and the next one.
Yeah.
Oh, that's fascinating. Okay. Well, why is that happening?
When you share it, you should have a presenter view or like the original.
Yeah, exactly.
View.
Let's see. No, the presenter notes, I'm not showing that. Apparently it wants to anyway. So let's try this. Swap that. And thank you, Q, for letting me know. How about now? Wonderful. It's because I have a second monitor plugged in. It doesn't like that. All right. So there's a couple of folks from my lab here. And this is a lab. Say hi, everybody. And so we primarily study brain oscillations, brain waves, brain rhythms. And our larger goal is to understand how these 86 billion or so neurons that you've got in your brain communicate with one another. And because we're in San Diego, I have to show the requisite San Diego on a beach pic with the lab. And it's pretty fun. And because it's Halloween, I'm showing the slide of everybody murdering me in Among Us during the pandemic. We tried to socialize and it was, as fun as we can make it. We had a good time. And so you're here though, not to talk about me or my lab or hear about any of that stuff. You want to hear about zombie brains supposedly. And if you didn't intend to do that, I don't know why you clicked on that Zoom link, because you were in the wrong place, because this is silly. All right, so why zombies? I've been doing this now for like 10 years. This is my favorite zombie inception slide. This is me talking about zombies. And this all began as a joke that went way too far. And so when I was doing my PhD at UC Berkeley, I was having a really hard time learning neuroanatomy. The neuroanatomy, for those of you who aren't familiar, right, is just understanding all the different parts of the brain. It's really complicated. There's no rhyme or reason to much of it. It's just straight up rote memorization, right? You have to understand that the prefrontal cortex is connected to the basal ganglia, and that connection is disrupted in certain kinds of disorders, and it has these neurotransmitters, and just go on and on and on, right? And there's Latin names for everything, and there's no clear understanding of things. And so I struggled a lot to try and understand neuroanatomy. I eventually ended up teaching neuroanatomy for several years because I ended up, I don't know if it's Stockholm syndrome or what, but I ended up falling in love with neuroanatomy and understanding that by looking at the structures of the brain, you can understand something about the evolution of cognition. You can understand comparative neuroanatomy. Why is our cognition different? For example, between us and other species, you can start to see some patterns maybe. And one of the ways in which I learned neuroanatomy so well is by working with Professor Marianne Diamond at UC Berkeley, who, when I took her class and then ended up teaching her lab, I want to say she was about 83, 84 years old. And she'd been teaching neuroanatomy at Berkeley for 50 something years at that point. And she was quite good at it after 50 years of teaching it. And she created the Human Brain Coloring Book, which was it's exactly what it sounds like. You color brain regions, and it was great. I was doing my PhD, and I would go and visit my family at Thanksgiving, and they'd be like, "What are you doing?" And I'm like, "Coloring in this coloring book," and I'm like, "I'm getting my PhD." Like, but it was a really great way of learning how to like all of these different details. And so I love that idea of taking something really complicated and breaking it into something that's a little bit more fun. And that's how the zombie thing started. And the way that we did that, and I say we because this is all done with the collaborator of mine, Timothy Versteinen, was we began by creating a fake scientific poster for a neuroscience research conference. And so if you've ever done like a high school science fair, you'll sort of remember how this stuff works, right? You have your little like science poster, and you're standing there and your teachers are coming by and grading it. That format still kind of holds true. Every year there's a Society for Neuroscience conference. There's about 30,000 people that attend this conference, and you stand in front of your poster in this large conference hall with thousands of other people that are presenting their research posters. And it's all genuinely serious science. And so we made this fake poster about zombie brains one year because we enjoyed using zombies as a way of teaching people about the human brain in a way that was a little bit more accessible. And we hung this poster up in the middle of this conference. And we just kind of stood back and like watched it. And we ended up calling zombieism, we created this sort of overly medicalized term, consciousness deficit hypoactivity disorder. And we pretended like we had zombies and brain scanners, and we scanned their brains using MRI, and we sort of looked at how their brains responded to different kinds of like fearful or stimuli or like blood or something like this, pictures. And we just kept joking with people. We're like, yeah, we had a really hard time getting the zombies to sit still in the MRI. And if you have motion in the MRI, you can't really get a good picture of the brain. And so what we found worked really well is if you decapitated zombies and just hung their heads there in the MRI scanner with duct tape, then it was like pretty good. We still had some, mouth movements and stuff, and people like, what are you talking about? But what slowly happened over the course of this conference is that like more and more people started coming over to it. And I have a picture, I didn't include in this talk, unfortunately, but my favorite is we have a security guard who was working at the conference came over and listened to us give our spiel about a zombie brain, and then called over some other security guards to listen to it. And I've been going to this conference for 20 years now, and never once has any of the research I've done been something that like the security guards working at the event ever stopped to listen to, right? And so to me, that was pretty amazing that we created this thing that we then had security who were working at this event. They're not there for neuroscience, they're not neuroscientists, but they had suddenly questions about the brain and different parts of the brain, and we're like, holy crap, this is amazing, right? It's a really good way of talking about something that's complicated in a way that non-scientists might actually care about. And this led me down a whole weird path of I go to Comic-Con every year in San Diego, of course pre-pandemic, and we're on panels about zombie brains and stuff, and I got to meet some pretty incredible people. And one of the years after Comic-Con, I got a couple of emails from people that were in the audience, and this is why I do this stuff, right? It makes science a little bit more fun, right? Because if I come into a room full of people at Comic-Con and I say I am very interested in understanding the role that electrophysiological periodic and aperiodic activity plays in coordinating information transfer between excitatory and inhibitory populations of neurons, nobody cares what that means, right? Because it doesn't make any sense, right? I may as well just like throw a bunch of Scrabble tiles on the ground and say that's what I do for a living, right? It's like it doesn't mean anything to anybody. But if I talk about it in terms of something that's a little bit more approachable, then I get comments like this from people. I got emails from people that were in the audience at this event saying, I'm a grown man with a family and a career, and Brad made me want to become a neuroscientist. And somebody else sent me an email saying, I accidentally started liking science stuff thanks to you. Right? And so we'll see. I don't know how long their interest in science stuff lasted. If the stuff of science, I'm not sure if that's like a good viable career option. But like I'm really glad that they found it interesting. And then this ridiculous thing that we did got picked up by a neurology today. So neurology is the medical branch of understanding, brain and brain disorders. And we got invited to talk at a neurology conference in front of a bunch of medical doctors, neurologists, about zombie brains, and that got picked up by Neurology Today, which is like a trade magazine. And then ultimately that got picked up by Wired magazine that wanted to create a infographic about using science to survive the zombie apocalypse. And New York Magazine then ran a special piece about the zombie brain at work. And so this was like a joke thing what we did. A couple of grad students that were interested in teaching people about the brain that then just kind of kept snowballing and getting out of hand until ultimately we got asked to write a book by Princeton University Press on taking everything that we'd done about the zombie brain research, right? And turning that into a introduction to neuroanatomy or neuroscience textbook. And so we, after a little bit of going back and forth, we're like, well, okay, if we write this book about zombie brains, we are absolutely going to just torpedo our careers. We're both at this point finishing our PhDs. Timothy Versteinen, who's now a professor at Carnegie Mellon, and myself, we were doing our postdoctoral research and like actually trying to be serious neuroscientists trying to figure out, you know, the grand mysteries of the brain, while also on the side writing a book about zombie brains. We're like, if we do this, nobody's ever going to take us seriously ever again. Thankfully, UCSD being UCSD, they really loved the fact that we were doing this. And Marta Kutis, who was the chair of the department at the time, I don't know if you've ever had the pleasure of taking a class with Professor Kutis, but you know, she was absolutely supportive of this when UCSD was hiring me, and it was a ton of fun to write. And you know, the book has sold literally dozens of copies to rave reviews on Amazon. You know, you can't get better than as described. That's really what an artist is hoping for. You know, there's no tricks being played on you. One of the more funny parts of all of this, though, was we got asked by TED, the TED conference. They have an educational series called TED Ed to narrate a animated video about the zombie brain. And so Timothy Versteinen and I, they shipped us a microphone and a little like recording booth that was the size of your head. So you like stick your head into this booth that's like very silent for recording. And so during my PhD, at the end of my PhD, I went down into one of the brain imaging recording rooms that I booked so that I could have a quiet space. And I'm sitting in this room with my head in this box with a microphone, and I'm reading about zombie brains off of my phone that's in the back of this box. And I'm like, what the hell am I doing with my career? I'm sitting in this brain scanner thing, like with my head in a box, and I'm talking about zombie brains to myself in a dark room. But these videos got like really popular. People really enjoyed them. And the ulterior motive we had, though, was, you know, and Bob, I hope you appreciate this, was also making fun of neuroscience. So there's actually research that has been done that has shown that if you take any sort of behavioral or cognitive phenomenon of interest, and then you add some fake neuroscience something to it, right? You just say, and also it's involved, you know, with the parietal lobe. Just by like making up some arbitrary something and saying, also scientists have found that this activates the parietal lobe or the hippocampus or something like that, then people tend to believe it more, even if it's totally made up and arbitrary. And there's this tendency, in my opinion, for some people in neuroscience to like overhype their research and make promises that they don't deliver on, right? As long as I've been in neuroscience, the cure for Alzheimer's disease has been like 15 years away. And I find that to be incredibly frustrating. It's doing a disservice to science. And so part of writing this zombie brain book was to sort of poke fun of that at that tendency and say, like, look, we can take reasonable sounding neuroscience stuff and apply it to something completely and totally ludicrous like a zombie, but wrap it into like all of this really plausible sciencey sounding terminology. And so not only do we want to do this in order to actually help people learn a little bit more about the brain and the history of how we understand how the brain gives rise to cognition, but also to poke fun at other neuroscientists in the sort of work that we all do. Okay, so with all of that said, I'm going to give you now the short and brief presentation about the science of surviving the zombie apocalypse. And I think the highlight of my career was in all of this, being invited to go to ZombieCon, I should say, in Seattle. And I got to interview on stage George Romero. And that name probably isn't going to be familiar to many of you, but George Romero was the original director of the 1964 Night of the Living Dead, which is the film that arguably started the modernity of zombies. Like how we think about zombies is what they are. And he created Night of the Living Dead, Dawn of the Dead, Day of the Dead, all of those films. And he was the original director, and we got to interview him and hang out with him. That was pretty cool. Okay, so understanding the zombie brain, first we have to actually understand a little bit about, we have to very carefully observe their behaviors in order to understand what the brain of a zombie must look like. And so in order to do that, you have to look through the plethora of research that has been done on zombies, by which I mean we had to watch a boatload of zombie movies. And so in doing so, this is zombie, by the way, we don't recommend you engage with these creatures. We discovered a whole host of specific deficits that are that really quantify or describe the overall behavior of a zombie. So addictive behaviors, the insatiable craving for human flesh, for example, aggression, memory impairments, impulse control problems, attention problems, language difficulties, motor deficits. So this is the cluster of symptoms that define consciousness deficit hypoactivity disorder. And so we understand quite a bit about where the neuromechanisms by which these different behaviors are instantiated. So because of that, we can make the reverse inference and say, given brain imaging data that we've collected about all of these kinds of things in normal healthy participants, we can then make an inference about which parts of the zombie brain must be impaired. And let's see, hopefully this works. We're going to do and hopefully it's not too loud. I'm going to share a video here. Can you all hear that? So this is a classic set of zombie traits. I love this movie. I have to watch it again. Okay, so if you aren't familiar with this is from Shaun of the Dead, which as a zombie enthusiast, I feel like I have to say that my favorite zombie movie is the original Night of the Living Dead. But if truth be told, I think Shaun of the Dead is probably my favorite zombie film. It's really funny, and it is written and acted in by people who clearly love the zombie genre. So there's a bunch of zombie film inside jokes in this movie. And if you haven't seen it, I highly recommend you go check it out. But anyway, so you can see here that there's these two zombies and they are slow moving, nonverbal. And you notice that they are throwing objects from this clothes hamper basket at them to try and keep them away. And they're not responding to any of these, including taking a toaster to the head. And so as a scientist, you make these kinds of observations and you ask yourself, why are these zombies not responding to a toaster in the head? These are the kinds of serious questions that we deal with in my lab. And so then you have to think about, well, okay, well, maybe your hypothesis is something pretty straightforward, right? You might say, well, maybe they don't feel pain. That's a pretty straightforward hypothesis, right? But it gets a little bit more complicated than that, because if you don't feel pain, then it turns out that your ability to actually interact with and move throughout the world is severely hindered, partly because when we move throughout the world, one of the ways by which we're not constantly like overextending our limbs and our muscles and tearing our own muscles is because we get constant feedback from the proprioception of our bodies in our muscles. Your muscles have they have sensory fibers in them that then signal back, and if you stretch too far, it hurts, right? You get sore, it feels bad. And so that tells you I need to stop moving, or otherwise I'm going to hyperextend or overextend my muscles. And so if you don't have that kind of constant feedback, then actually making very simple movements and interacting with the world becomes very difficult. And so our hypothesis isn't that the zombies don't feel pain, it's that their sensation of pain is constantly being suppressed. So they feel the pain, but they don't care about the feeling of the pain, if that makes sense. And so this is the kind of inferences that we ended up doing throughout this. And so again, sort of as the joke, we decided that we would create zombies as a clinical disorder, where we define consciousness deficit hypoactivity disorder, or CDHD, as the loss of rational, voluntary, and conscious behavior replaced by delusional impulsive regression, stimulus-driven attention, and the inability to coordinate motor or linguistic behaviors. I can't tell you how much fun we had sitting around drinking beers and like working with our friends on this and trying to define this stuff. It was a pretty fun couple of weeks of working through all of this zombie stuff. And so my buddy Kim Versteinen, who's an expert in MRI brain imaging, so fMRI and what's called DTI, diffusion tensor imaging, which is imaging the white matter tracts of the brain, created this image here where a normal human brain is in gray And the hypothesized zombie brain here is in orange. So you can see that the hypothesized zombie brain is missing gray matter in many different parts of the brain, including here. If you're not familiar with looking at these kinds of image, this is called a transaxial slicing of the MRI image. So axial meaning this way. So, if you just like imagine slicing through my head in this kind of segmentation here, starting at the very bottom on the left is the cerebellum, which is this part of the brain at the very back here, sort of cauliflower shaped looking thing. And the cerebellum, even though it's only about 15% of your overall brain size, it contains fully 50% of the neurons in your brain. And the cerebellum is kind of a mysterious thing. So there are people who are born with what's called cerebellar agenesis, which anybody want to take a guess what that means? Genesis is the creation of, so agenesis would be the lack of creation of. So cerebellar agenesis is something where people are just born without a cerebellum. This means that they're born fully missing 50% or so of the neurons in their brain, and you can't really tell. Like people with cerebellar agenesis don't have any very clear, obvious outward-facing cognitive or behavioral deficits. Their ability to walk is a little bit different, but the most striking thing, and I miss doing this kind of lecture in person because there's sort of demonstrations I can do about what this looks like. But if they close their eyes, they begin to sort of sway, they lose their sense of balance. As far as we can tell, 50% of these neurons in your brain, in the cerebellum, are doing the incredibly difficult task of sensing and controlling the fine motor movements of your body to keep your body oriented physically in space. And if that sounds really like difficult, you can imagine, you look at like videos of the Boston Robotics dogs and stuff like that running around and trying to like keep their balance in those robots. I don't know if people have seen this, but programming robots in order to move through the world on 2 legs or even 4 legs and interact with it, let alone to be able to do like really fine motor control of like taking my keys here and like taking that little ring and then I have to open that ring, right? And I got to like flip it through, or, weird little things that we can do, like, we can flip, rings and stuff like this between fingers, like all of these weird fine motor control movements that we have to create and build things. If you were to program that into a computer, I mean, I can't even imagine the amount of work it would be, right? It would be like, if I pick up my water bottle, I have to extend my arm, 73.4% and rotate my, wrist by 6.1 degrees and then grasp with this many, newtons of force to be able to pick it up, but don't grasp it too strongly. I mean, I'm not strong enough to crush this, but like, we can grab delicate things and, you have to grab them just enough that they don't slip through your fingers, but not so much. We think that this is probably what the cerebellum is doing. And so we think in the zombies, the reason that they move with that slow sort of shuffling stagger motion that they do is because of severe deficits in the way that the cerebellum is either operating or computing information. So with the cerebellum as dysfunctional as it is, they can't keep their body physically situated very well in space without a lot of effort and visual feedback. And then one of the other clusters of symptoms that we observe in zombies is amnesia. This is from Land of the Dead.
They're trying to be us.
No, they used to be us. Learning how to be us again.
No way. Some germ or some devil got those things up and walking, but there's a big difference between us and them. They're dead. It's like they're pretending to be.
So I love that scene because it's sort of like, if you're familiar with Pavlov's dog, right? Intro to psych level stuff. You hear the bell ring and the dog behaves, right? It has this unconscious behavior. It starts to drool because it's expecting a treat because the researcher paired the ringing of a bell with giving the animal a treat, giving the dog a treat, right? And so it begins to associate the sound of the bell with an outcome, right? And this film takes place in New Jersey, which is one of 2 states other than Oregon that doesn't trust people enough to allow them to pump their own gas. And if you've ever been in New Jersey, maybe that's a reasonable assumption to make. But in this movie, you've got people from New Jersey. I'm just sticking at friends in Jersey. All right. So if you've ever been to one of these gas stations, you actually, when you drive in, you drive over this air-filled tube, and that tube causes a bell to ring, which then tells the gas attendant to come out and pump the gas, right? And this is after the zombie apocalypse takes place in this movie, that the bell rings because a zombie steps on that air-filled tube, and the gas attendant, the former gas attendant, comes out and goes to pump the gas and looks around and is kind of confused. I love this, right? Because this is like showing that even after the zombification in this film, this zombie actually still like has a habit of its old job, its pre-zombie life. And so it's still trying to do the behavior that it's supposed to do, but then it kind of looks around and all confused. If you haven't seen the movie, that zombie there ends up like leading this zombie revolt, like starts organizing the zombies to fight back against the humans and stuff. It's a cool movie. I really enjoy it. And this other last one that I'll talk about is attention deficits from the same film.
How come you guys always go out at night? Wouldn't it be safer in the daytime?
Fireworks, kid. Dentists can't keep their eyes off them.
The tambourine in the gazebo guy is my favorite. Like, I'm trying to imagine that guy's backstory. Like, okay, the zombie apocalypse is all around you. There's like zombies terrorizing the world. And so your response to that is to grab your tambourine and go hang out at the park until a zombie bites you. Like, what is that guy's backstory wherein he's a zombie now and he's just walking around with a tambourine? Anyway, so what this clip shows is that the guy asked, like, wouldn't it be safer to go out during the daytime? Like, why do you all go out at night when they're going on raids to try and find food and supplies? And what they do is they shoot off fireworks, and all the zombies look up, and they can't help from looking up. Now, the amnesia that I showed you in the previous clip, that is a kind of a demonstration of a form of amnesia that can happen in some people, where if they have very severe damage, this is very rare, but very severe damage to their hippocampuses, both on the left and the right sides of their brain, they can no longer form new memories. This is a classic case in the history of neuroscience. Patient HN, Henry Malazan, after he died, his name was unblinded, and his family sort of told his story a little bit, who had brain surgery to try and cure his epilepsy, severe seizures. And the surgeon in the 1950s removed both his hippocampuses on the left and right because that's where the seizures were coming from. When he recovered from the surgery, he was seizure free, but he could no longer form new memories. He remembered everything from the life prior to the moment of the surgery, but he could no longer form any new memories. So his memories would reset after the span of a couple of seconds. It's a fascinating and tragic story in the history of neuroscience. Much of neuroscience is actually driven by these kinds of, like, most of what we know about the brain is actually driven by these kinds of tragedies. And you know, I don't want to belittle it. It's pretty severe, but it's remarkable to me how much knowledge has been gained in the field from these kinds of scenarios, right? And similarly, this attention deficits, there is something called Balint syndrome, which is a neurological syndrome that is caused by damage to both the left and right posterior parietal cortices. So a little bit back here, but on both sides. And patients with Balint syndrome, it's very rare. Again, it usually only happens if you have a stroke that damages both sides of the brain simultaneously, or I guess that doesn't have to be simultaneously. So it's very rare, but these patients report having what's called stroboscopic vision. So rather than seeing the visual world and experiencing life in smooth, continuous visual movements, they report seeing the world in snapshot frames. It's like the frame rate has been lowered on their visual world. And they have a very difficult time directing their attention. Their attention is easily captured by surprising things in the environment, right? And so these are real things that do happen to real people. And so it's pretty remarkable to me that you can look at this history and these filmmakers who have no idea about really any of this stuff. I mean, I know that Romero had no idea because I got to ask him, right? I asked him in this conference, why did you, at the time in 2010-ish, by the way, in the zombie community, there was this big fight about whether fast zombies were real zombies or not. So there was this like fast zombie versus slow zombie contingent in the zombie fandom. And so I got to ask Romero at this panel, I said, well, you know, in the original film of Night of the Living Dead that you made, why did you decide to make your zombies so slow? And it was the funniest kind of thing, because this guy looks at me and he's like, you're a PhD smart guy, because they're dead. And I was like, oh, okay, all right, that makes sense. Are you sure it's not because they have dysfunction in the cerebellum or basal ganglia? Right? It's like, no, that's not what the filmmaker is thinking, right? But they are these filmmakers are managing to incorporate all this really cool information to tell an interesting narrative. And by telling these interesting narratives, the zombie filmmakers are trying to tell stories about people, humanity, how we interact, right? The original Night of the Living Dead was a story about racism in the United States. And Land of the Dead, the follow-up, or I should say, sorry, Day of the Dead, the follow-up, was a story about consumerism. And zombie films, Return to the Living Dead in the 1980s was a story about fears of nuclear war and nuclear destruction, right? Zombies are an amazing medium to tell stories because they represent essentially a blank slate for talking about something that is concerning society at its core: racism, consumerism, it's the destruction of our species through war, right? And zombies allow you to tell these different stories. As a neuroscientist, I love this because it's a similar blank slate. It allows us to tell stories about the history of neuroscience in a way that is maybe a little bit more engaging than reading yet another textbook about neuroanatomy. And so anyway, that's it. We're over time now, so I'm going to stop sharing. And I could stick around for a little bit longer if people want to take questions. I don't have to leave quite yet, but I'm happy to chat with people. Zombie gatekeeping, yeah, totally. Oh, you had gray boxes at the top of the slide. Sorry, everybody. I'm not really sure. Those might have been the presenter sort of buttons and stuff. What about a zombie with ADHD? Well, we can sort of work through that. We can try and figure out if a zombie could have ADHD based upon what we suspect the neural mechanisms, or I should say the neural basis of ADHD is, which we don't really have a very good idea at all, and what the neural basis of zombieism is. And then we could decide if they're compatible.
So we don't have a good neural basis of like attention deficit disorder, or what about like things like OCD, other like developmental brain disorders?
Well, Professor Deanna Green was on this call. I don't want to make her mad. Is she still here? Deanna, are you on still? I don't think so. Okay. No, we really don't. Right? Like there are only a handful of disorders that. No, I'm going to stop.